Hello everyone, this is Poonam Deshpande, and I'm going to teach you how to find the particular integral that is a part of a solution of higher order LDE using different standard forms of X. So before we start understanding how to calculate YP, please recall that the general solution of higher order LDE is nothing but a sum of the complementary function and the particular integral. In the previous lectures, we have studied how to find complementary functions using different methods, and this particular lecture we are only concentrating on how to calculate YP. Now we already know that YP is nothing but 1 upon FD operating on X. Now 1 upon FD is some type of integral operator. Now what is the type of integral operator that we will see when we learn the methods. Now we already know how to calculate YP using different types of FD which has been done in the classroom and in the previous video lectures. So let us recall that if 1 upon FD is 1 upon D, that is nothing but just an integral operator, so it is just nothing but integration of x dx. Similarly, if you have yp equal to 1 upon d square operating on x, it is nothing but just the integration of x two times. Please remember that this is not a double integration, but this is a successive integration. So that means you integrate x once and twice. In a similar way, 1 upon d raised to n operating on x is nothing but the integration of x n times. So this is not n integrals, it is the successive integration of x happened over n integrals. Now we already know that fd is nothing but a polynomial in terms of d, and which can be factorized into linear factors. So if the linear factors are of this type, say d plus a or d minus a, and when these operate on x, then you have a direct formula. You can see these direct formulas. So this is just a quick recall or recap of what we have done in the previous lecture. But what we are supposed to do is, now let us understand how to calculate YP using different types of X. Now here I am going to give you a table which is consisting of the list of standard functions of X and their corresponding particular integrals. So what we have here is, the first column is X, where this will give you the standard types of functions. Then what substitution should we make to find YP, and third column is YP, what exactly YP that we are going to get. Although this table just gives you brief idea about what exactly is to be done, but in the successive video lectures I'm going to deal separately for each of the standard functions, that is e raised to x or sin x, cos x, etc. So let us start with the first function, that is e raised to ax. So whenever your capital X is e raised to ax, what we do is we replace every d in f of d by a, and therefore what we get is yp is equal to 1 upon fd, which operates on e raised to x, is equal to 1 upon f of a operating on e raised to x. Now since a is a constant, whenever you substitute a in terms of in f, what you are going to get is some value or some number, and it is nothing but going to be your final answer. Okay, but this is valid only whenever there is a special case, and what the special case is, that we will see in the successive lectures, which will individually deal with each of the standard functions. Okay, now next let us go to the trigonometric functions, that is sin ax and cos ax. You can see that for both the functions the substitution to be made is exactly same, and even the yp will be exactly same. So what we do is, in fd you replace every d square with minus a square. Even for cos also you replace every d square with minus a square. So what I'm going to do is, I'm going to write this f of d as some function of d square, say phi of d square. So this is still fd, but I'm rewriting fd as some function in d square. So I'm treating the function fd as a function of d square. And then what we do is, for every d square you substitute minus a square. So then this will become 1 upon phi of a square. So similar to f of a, this will give us some number or maybe some expression in d, and that we will see separately when we go for individual lectures of each of these functions. So you can see that for cos and sine, for both the functions we have the similar substitution and similar yp. Let us come to the next function, standard function, that is x raised to m. Okay, so whenever you come across this function, what we do is you replace fd. So we rewrite fd as 1 plus phi of d. So suppose your function is d square plus 2d plus 2. So what you do is I am going to separate one out, and then whatever is left I am going to write that as phi of d. So that means yp that I am going to get is 1 upon fd. So since fd is to be replaced with 1 plus phi d, so 1 upon fd operating on x raised to m will give me 1 upon 1 plus phi of d x raised to m. Now what we have to do with this, that we will discuss later on in the individual lecture series. Let us come to the next function, that is e raised to x times v. We have come across this e raised to x earlier here. I have already told you what to do with whenever you come across x as e raised to x. But here what we have is e raised to x into v. Now what is this v? V is some function of x other than e raised to x. Because if it is e raised to ax, then you just add the indices. We don't want that. What we want is, we want v to be a function of x which is other than e raised to x. So whenever you come across such function, what we do, we replace every d with d plus a after taking out e raised to x from the operation. So what is the meaning of this? That means if yp is equal to 1 upon fd operating on e raised to x times v, where v is some function of x other than e raised to x, then we take out e raised to x, and when we take out, what we do is we replace d with every d with d plus a, and now 1 upon f of d plus a will operate on a v. Now v can be any other standard function other than e raised to x. That means v can be sin x or cos x or x raised to m, because since till now we already know these three standard functions. Okay, so now again in detail what is to be done exactly in the example we will discuss later in the successive video lectures. Now the last function is x into v. Now again v is a function of any function of x other than x raised to m, because if it is x raised to m, then simply this will become x raised to m plus 1. So we can use the method of x raised to m, but we are not going to do that. So v is a function which is other than x raised to m, and therefore what we do is we replace the entire fd with this particular operator. Do not worry about this particular operator. I am going to tell you and teach you how do we operate this operator on v. So what happens is, yp is 1 upon fd operating on xv gives you this particular operator. Now this is very important, that this particular operator, there is an order in which it operates on v. So what we do is you operate on v 1 upon fd first, and then whatever answer that you get, you multiply this answer into the bracket, so you get x into the answer minus this particular term into the answer, and then you operate f dash of d on the answer, you will get one more answer, and then you again operate 1 upon fd on that answer. So finally you will get answer, and that is going to be yp. So that's it for this particular lecture, and for the successive lectures we will be dealing separately with e raised to x, sin x, etc. That's all for now. See you in the next lecture.